Welcome to the second devlog of this yet-to-be-titled RPG. Last time I set up a little test scene and implemented a simple interaction system for displaying messages, picking up items and starting battles. Today I want to show you a few systems that aren't part of the actual gameplay but support it. First, there is controller support. Overall, simply enough. Just go to the input map settings and add the joystick and face buttons to the already existing input actions. What took me longer than it should, however? When using keys only for the input, one has to normalize the input vector. That means dividing it by its own length to make it have length 1, because otherwise the player will be faster by a factor of square root of 2 when moving diagonally. The vector2 function that does that is appropriately called normalize. For joystick input, we want the actual input though, because that allows us to move at a slower speed when the joystick is only pressed slightly to one side. To combine these two cases, we don't want to normalize the input vector, but limit its length to 1. That way, the vectors that are too long get cut down, while the shorter vectors aren't scaled up. But what I thought I remembered, maybe from Godot 3, is that the vector2 function that does this is called clamp. I couldn't find it in the documentation and was about to start implementing this myself. But I found limit length. In Godot 4 this is called limit length. Next up was the main menu. Without too much thought, I just threw a few buttons onto a color rect, together with the version number, which is stored in a settings autoload. I always like to store the version number in the save game data. That way I can check whether a save file is from before I refactored a significant part of the game and can make adjustments to the loaded data. Apart from that, the version number is super handy to have on display for playtesting, of course. Another little trick for playtesting I started to use a while ago: I will change the background color of the main menu regularly and especially for certain builds. For example, when introducing a new major mechanic. That way I can ask people whether they played, say, the pink menu version of the game, instead of having to ask about like version 1.12.78 or something like that. I also added a simple splash screen to the game. This particular logo design is from StayAtHomeDev, or rather an artist commissioned by him. Link in the description. I always like to have a custom splash screen early on in development. That way, when I test the game, it is easier to see whether I loaded the full game from the very start or from a specific node, which might have limited functionality when run on its own. For actual game systems, I started with a level loading and scene transition setup. Nothing too exciting though. I created a node called Teleporter, which is basically just an area 3D, which asks my game manager to load a new level when the player enters its collision shape. To make things easier to design, it has a few export variables, like whether it's active or not and obviously what the target level is. But it also has a spawn point I can set. I added a node to my level template where I can add markers. The teleporter then can choose on which of these markers the player is supposed to spawn at. The actual levels themselves simply get set as the current scene in the Godot sense, i.e. they are the main child node of the root. In the past, I often used the game manager itself as this main root and then have it have all levels, menus, GUIs, etc. as children that get swapped out. But for this project I wanted to test this other system, the game manager being an autoload and the current level or menu being the current scene. While working on the level loading system, I decided to also set up everything for fancy screen transitions. At the moment it's just a fade to black though. I added a canvas layer as an autoload, set its set layer to something high, such that it is rendered above everything else, and gave it a color rect. Then, whenever I load a level, a tween is created and interpolates the color of the color rect. First to black and after loading back to transparent. In the future I might create shaders to imitate transitions seen in other RPGs. But that's not important for now. The last big thing I wanted to tackle for this devlog is the save and load system. In and of itself, relatively easy, especially since I did implement such a system a few times in the past. My go-to process is to have a global node which keeps track of all information that should be saved, and then write a function that chucks everything into a dictionary and serializes it. For this project, this will be done by the game manager. For stuff like the inventory or player stats, that's all fairly straightforward, I hope. But there will be objects in the various levels that might change their overall state. So far, I identified only 2 types of these objects. First, objects might not be there anymore. These are things like pickups or boss enemies. Second, objects might have a variable that is set to something else than at the beginning of the game. A treasure chest might be permanently open after the player, well, opened it. So the lid of the chest has to be rotated. Or an NPC might have moved to a different position during a cutscene. Or a fruit tree that regrows fruit every 30 minutes has to save and load the internal time of the growth process. Because of the second case, we will have to store an actual value, a variant in Godot terms. And on load, both cases do very different things. So we have to explicitly implement both behaviors somewhere. My first instinct was to create a new component that can be attached to the objects that need to be updated when the level loads. They then get a group call to update their parents to make the appropriate adjustments. But then I worried that it would be quite tricky to keep track of what is saved and loaded over time. I think I want a more centralized ledger for that. So here is what I will do. All objects sit inside a level scene, where level refers to a single village, dungeon, forest, etc. All of them inherit from a base scene, which has a script called Level Manager. Recall that this is the current scene in the scene tree, so it sits at the very top of the game tree. Technically, that means it's a sibling of the Game Manager and all other autoloads. But morally, the Level Manager is only allowed to do stuff in the level itself, while the Game Manager can do anything. So it sits above it in some sense. And the Level Manager is where I will keep track of which properties of which objects shall be saved and loaded in a so-called ledger. And this is also where the updating of the actual objects will take place. So if I come back to a level in the future, it is much easier to see what's going on there. For now, I will write this into the script attached to each level. In the future, I might create an editor tool for that, but we will see. Now, here's the current complete save load cycle. When the game starts, the Game Manager loads the save file with all potential changes in all levels and stores that in a variable. When it changes to a new level, it will give this level the information about what the current values for its objects are. The Level Manager then updates the objects appropriately. Delete the objects that shouldn't be there anymore and set variables of objects that somehow changed. Saving is done from the bottom up. I extended my interactable components such that they can request the Game Manager to trigger a save. They only say that something should be saved, but not what should be saved. Simply because what happened in the interaction and what needs to be saved afterwards might be very different things. The Game Manager then tells the Level Manager to read all data that needs to be saved and to send it back. At the end, the Game Manager serializes the data and saves it in a file. It feels like this is a reasonable way to cluster the information and actions for saving and loading. And it makes it easy to implement both manual saving by the player as well as autosaves. The last big structural aspect to think about is the following. It is very much possible that an event in one level changes something in another level. Since only one level is loaded at a time, we have to have some global reference for all levels. That is done, of course, in the Game Manager. Should be easy enough to actually keep track of the data the way I implemented everything. But I'm not sure yet how I can trigger that in an understandable way. We will cross this bridge when we reach it. But maybe I will move the information about what to change somewhere else after all. In any case, this is enough scaffolding for now. For the next devlog, I want to tackle the basic implementation for a battle system. To have a somewhat consistent style, I will probably also add a few more placeholder sprites for heroes and enemies. Thank you for watching, and until next time.